not sure it does. I think with the level of commitment required to moving forward with the GigaCast program, you need to be very firm on your architecture. So actually there isn't a lot of room for making small incremental changes. Once the die sets are in place, it's what you've got. It takes a lot of time and a lot of money to take out and make modifications to die sets. So that lack of flexibility is both an opportunity and a risk. It's a risk in that if you get something wrong, it can be very costly and very time consuming to get right. Hence the value in prototyping these parts, because you can see what you're going to get in advance of that before you have to make this multi-million-dollar commitment to the final production tooling. But equally, having that inflexibility can drive a discipline back into the design process, knowing that there is no opportunity to do service fixes or can you just tweaks and modifications, mean that the quality of engineering has to be there in the first place. There is very little opportunity to recover. So it drives that discipline into the process, it drives the discipline into the engineering, it drives the discipline into the strategy to say, this is a commitment we are making to our vehicle line for the next 5 or 10 years. And these become the hard parts of the vehicle. And everything else around that vehicle needs to be designed to work with that, rather than the assumption that everything in the vehicle is up for change. So it sets a hard point, and that's very important in automotive, where design flux is apparent right up to the final launch stages. To have that hard baseline that can't be changed is very valuable.